Section 2.2 of your text introduces the derivative function, and the derivative function is defined as follows. The function f prime is, and f prime is how this symbol is read, defined by the formula f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. And we have to think of this as a function. Notice if we wanted to calculate f prime of 2, all right, we'd have to go through here, and every place we see an x, we could replace it by 2 and then take that limit. Or f prime of 7, all right, replace the x with 7 in all instances and take that limit. All right, anyway, this function is called the derivative of f with respect to x. Notice the change in f in the numerator. H we've seen already would be the change in x in the denominator. The domain of f prime consists of all x in the domain of f. We have to be in the domain of f. We have to be able to evaluate f of x to take this limit for which this limit exists. And then we have to be able to take this limit to evaluate this function. The function value in this case is a limit value. All right, let's see where this comes from. Notice that if we look at the average rate of change in f over the interval from x to x plus h, well, at one end of that interval, the x value is x, and the y value is given by the function f of x. So at this end of the interval, on the graph, we have the point x comma f of x. At the other end of the interval, the x value is x plus h. So the y value is f with the x replaced by x plus h. So all instances of x would be replaced by x plus h. The change in x is going to be x plus h minus x, which is equal to h. All right? And that was what the denominator, the change in x is in the denominator. The change in y is going to be the difference between these y values in the same order, the bottom minus the top, f of x plus h minus f of x. And so the average rate of change in y with respect to x, or in f with respect to x, we could say, is going to be f of x plus h minus f of x all over h. And then let me just copy this last expression. And then if we would take the limit as h approaches 0, as the one end of the interval approaches the other end of the interval of this expression, that would give us the instantaneous rate of change in f with respect to x, or in y with respect to x. And this is what we're calling the derivative of f evaluated at x. Notice f prime of x gives the instantaneous rate of change in f with respect to x, or in y with respect to x.